what I want to do is I want to step back, and I want to sort of look at the structure of this function. And what I see on number 1 is that I see that I've got 6x squared plus 5 times x cubed minus 7. All of that has a big hug around it of parentheses that are then taking all of that raised to the 4th. And so whenever I see like a big bear hug like that, I'm thinking of an inside function and an outside function. So I'm thinking about a composition of functions. So my first strategy here is to think about the chain rule. And so in this one, my inside function is 6x squared plus 5 times x cubed minus 7, and my outside function is x to the 4th. So I'm going to do the outside function first because that derivative is much easier. We've got the derivative of x to the 4th is 4x cubed. Now as far as this inside function goes, if I want to take the derivative of this, I have two options. One is to FOIL this out, expand it, and then take the derivative, or I have two functions multiplied together, I can use the product rule. So our derivative of our inside function, product rule says first times derivative of the second plus second times derivative of the first. So we've got first, which is 6x squared plus 5, times the derivative of the second. So derivative of x cubed minus 7 is 3x squared, plus second, x cubed minus 7, times the derivative of the first. So derivative of 6x squared is 12x. All right. So again, we could have multiplied this out and then taken the derivative, and then we would not have had to use the product rule, but I wanted to use the product rule anyway. Okay, so now our chain rule, we're going back, we've worked with our inside and our outside, and so g prime of x is going to be derivative of the outside, keeping the inside the same. Now my outside is 4x cubed. Everywhere in this outside function that I see an x, I replace that x with my inside function. So I've got 4 times 6x squared plus 5 times x cubed minus 7. And that entire inside is raised to the 3rd power. Derivative of the outside, keeping the inside the same, times the derivative of the inside. Now the derivative of the inside is this entire expression up here. And because that's so large, and there's an addition sign in there, I'm going to group my entire derivative of the inside the square brackets. So we've got 6x squared plus 5 times 3x squared plus x cubed minus 7 times 12x. And there we have our derivative. Derivative of the outside, keeping the inside the same, times derivative of the inside. All right, any questions or comments about number 1?